Good morning everyone. Today, I will present our work, titled Revisiting Audio-Visual Segmentation with Vision-Centric Transformer, in collaboration with colleagues from HFUT, BUAA, CAS, and Sankfor Technologies. In this work, we rethink how audio and visual signals should interact to solve the task of sound-producing object segmentation in videos. The task we address is called audio-visual segmentation, or AVS. Given a video and its associated audio, the goal is to generate pixel-level masks for all the objects that are producing sound. This requires the model not only to understand what is making sound, but also to locate it precisely in the visual frame. Most existing methods use audio-centric transformers, where queries are derived directly from audio features. However, this leads to two main problems: perception confusion due to mixed sound sources, and loss of visual details because visual information is integrated late. To address these issues, we propose a vision-centric framework. It uses visual regions to form the initial queries, then iteratively integrates audio cues. This results in more precise and robust segmentation of sound-emitting objects. Here is an overview of our proposed framework, which we call the Vision-Centric Transformer, or VCT. The idea is to start from vision-derived queries and refine them through a multi-layer transformer decoder. Each query interacts with audio features to determine whether it corresponds to a sounding object, and with visual features to refine the object's boundary. This decouples semantic identification from spatial localization and enhances both. To construct high-quality vision-derived queries, we design a dedicated module called Prototype Prompted Query Generation, or PPQG. It generates queries that are both semantically aware of audio categories and visually focused. The module has three main steps: visual embedding aggregation, audio prototype prompting, and pixel context grouping. The first step of PPQG is visual embedding aggregation. We take high-resolution features from the early layers of the visual encoder and compress them into a set of informative embeddings. These serve as our initial vision-derived queries. They preserve spatial details and ensure diverse coverage of the visual scene. Then, we define audio prototypes to prompt queries with audio event categories present in the scene. We design a prototype audio contrastive loss for audio prototype learning. Finally, we improve the distinguishability of queries by assigning each pixel to one embedding using Gumbel softmax-based hard grouping. This way, each vision-derived query becomes more focused on a specific image region, leading to better interaction with both visual and audio features during decoding. We evaluate our method on the AVS bench dataset, which contains three subsets: S4, MS3, and AVSS. Across all of them, our method outperforms prior state-of-the-art methods by clear margins. Notably, on the challenging AVSS subset, we achieve the best MJ and MF scores even with lower resolution inputs compared to some baselines. Our ablation studies show the effectiveness of each component. Replacing audio-derived queries with vision-derived ones gives consistent gains. Adding group attention and audio prototypes further improves performance. The results confirm that our vision-centric design and prototype guidance are both critical. Here are some qualitative results. Compared to a strong audio-centric baseline, our method can better separate overlapping sound sources, correctly focus on sounding objects, and avoid false positives. The vision-derived queries allow for better discrimination of spatial regions, even under audio noise. In addition, we also visualize the logit maps predicted by audio-derived and vision-derived queries within the transformer decoder. Our vision-derived queries are able to focus on diverse visual regions in the image, demonstrating that vision-derived queries are more distinguishable. To summarize, we propose a vision-centric transformer with prototype prompted query generation for accurate audio-visual segmentation. Thank you for listening.